Okay, this is lab number 5 overview. This lab number 5 is going to be divided into part 1 and part 2. This overview is going to be part 1, and the idea is to demonstrate how to create a layer 3 leaf and spine fabric using the border gateway protocol. Now, the mode of operation for VGP used on this lab is going to be the E external VGP. It's just, it's just easier to configure. We don't have to worry about router reflectors. We don't have to worry about um, all the different tuning that goes on into the interior border gateway protocol. So we're gonna get rid of that. We're gonna use eBGP, and it's gonna be everything easier. The lab basically is gonna have a couple spines, like we've been talking on previous labs, especially the one that has the OSPF lab. And then if you look over here, we have a leaf one that is not tied to the other one, is separated. And then we have leaf 2 over here. Just imagine that you have a three-tier layer architecture, right, in which you have your L3 switches, which are going to be your core switches, right? And then let's imagine that these switch 1 and switch 2 are going to be collapse cores. No, collapse distribution and access. And the demarcation line is going to be here. From here up is going to be layer 3, connecting to the layer 3 cores. And then from here down is going to be the layer 2 adjacency for, let's say that this is a rack, and on this particular rack, let's say that you have 15 servers, and then you have some storage devices that are IP based. Okay, so having said that, this is gonna be probably in one of the floors or in one of the buildings, right? And the idea is to connect this switch right here, which is a single leaf. In this case, it's gonna be leaf 1, and which is gonna be this one right here, leaf 1. And let's draw another rack. Let's copy this. And let's say that you have another rack in a different location, and so basically what you do is that you connect your distribution access, one going to core 1 or spine 1, and then the second port on leaf 1 goes to spine 2 or core 2, right? Let's start labeling these switches, routers, multifunction switches, right? All kind of terms that I'm throwing at you. So this is spine 1, and this is gonna be spine 2, and this is gonna be the leaf that is gonna have the distribution and access layer collapsed. And then we're gonna do the same here, right? Layer 3, let's use color orange. Layer 3 come on. So layer 3 over here, and then going to the other. There you go. Okay, so that way we have our connections going to the cores, and that's the idea here. Like maybe this is like rack 1, right? And perhaps this is rack 2. So that's how the labs kind of looks like. So let's keep on labeling things just to keep everything rack 1. Let's call this other rack 2, and over here let's do this rack 1 and rack 2. So that way you have a visual besides just looking at these routers. So this is one scenario in which you can use this routing protocol BGP, that you can have multiple racks, so you can have multiple spines, so it can really grow east west. No, well, it can really grow by adding more spines just in case you need more performance, and the layer 3 is just really nice to tie systems that are in different locations, for example. What else? Okay, so the next part here is going to be to identify um, on the right. I have all the commands for each of the switches. So if we look at the column on the left here, this one right here is going to be for switch 1, which is going to be leaf 1, which is going to be in rack 1, for example. Then on the next configuration to the right, we have switch 2, which is going to be leaf 2, and leaf 2 is in rack 2. And then if we move to the right here, we're going to have the spine 1. Spine 1 may be in rack 1 or rack 2, or maybe it's in a different location, maybe in a different building in the on a campus, right? So it doesn't have to be in rack 1, or it doesn't have to be in rack 2. It can be in a different part of the campus, or a city, or so in this case, a spine 1, it can be in either rack. Spine 2, which is switch 4, the same thing with as a spine 1, right? It can be in a different location, it can be rack 1, it can be rack 2. Normally these two go together in the same location. Maybe spine 1 goes in one rack, and maybe spine 2 go in a second rack, so that way you have some type of flexibility just in case you need to down one of the layer 3 switches in that particular rack, while leaving the other spine in a second rack that is available and forwarding traffic. So that's the idea. So now that I have identified these different pieces of this topology, and able to translate it to a common use, let's continue checking all the pieces on this lab. So another thing to take a look here is going to be because this is going to be a routing protocol that uses TCP transport to create relationship between neighbors. For example, let's say that you have leaf 1. Leaf 1 need to establish a neighbor relationship with spine 1 neighbor, and then it need to establish a neighbor relationship with spine 2. Okay, so those are going to be the neighbors for leaf 1. And then for leaf 2 establish a neighbor relationship with spine 1, and establish a neighbor relationship with spine 2. And because we need to provide some type of router identifier, in this case we're going to use the loopback in the VGP process as the interface that is going to identify this router 3, for example. So if we go to router 3, the loopback 0, we're going to assign an IP address of let's see here, it's going to be 1.1.1.3/32, because it's a loopback address, and it's going to be this one right here. I'm going to mark it on the right, and I'm going to put the check mark that is already where I already have it in my configuration list. So the other thing I need to do is to make sure that switch 4 or spine 2 has is IP address 1.1.1.4/32. So this one, which is going to be switch number 4, 1.1.1.4/32. Then the next router that we need to provide the loopback interface so that way we can identify it into the VGP process. It's going to be 112/32 for switch 2. So this one over here, the loopback interface, is going to be 1, 1, 1, and 2. And then finally, let's check it. Let's finally switch 1 is going to have loopback interface of 1, 1, 1, 1. Yep, checked. So now we have loopback interfaces to identify leaf 1, leaf 2, spine 1, and spine 2. So let's keep on moving forward. Then we're going to configure the interfaces on each of the routers. So in this case, if we look at switch 1 or router 1, right here, router 1 is going to have a demarcation line here, down to the downlinks to the servers and storage. It's going to be layer 2 mode, and then for the uplinks it's going to be layer 3, just like I explained over here on this 3-tier architecture. This is the demarcation line, layer 3. I mean, for the layer 3 and layer 2 boundary, not for the demarcation line from the telco or ISP. This is more like a boundary, the layer 2, layer 3 boundary, just to make it clear. And on the other rack 2, yeah, we're gonna have the boundary for layer 3 and layer 2 over here. Layer 2 for the downlinks, layer 3 for the uplinks. Okay, so but another thing we have to do in VGP is that we have to enter like this interface IP address for 2, the IP interface for 3. We need to manually enter it into the VGP process. So let's take a look at switch 1, interface 112, which is this one right here, 112, and 172.16.3.2, 172.16.3.2. So that's checked. Let's check 113. 113 is 172.16.7.1. 172.16.7.1, so checked. And all I'm doing here is just to making sure that I show you all the parameters that are going to be entered in the configuration and verification video part 2 for this lab 5. Let's continue going down the road. 114, there is a description link to server 1, which is going to be this one, server 1, and that 114 is going to be switch port mode trunk. So this is going to be a trunk because perhaps we have ESXi running on this server, and we have multiple VLANs, but for now we're going to have VLAN 10, going down that trunk right here, this trunk right here. So we need to allow VLAN 10 on this trunk, okay? And then I'm going to stop there. Let's go ahead and check switch 2. Interface 112 is going to be 172.16.4.2, 172.16.4.2 checked. Interface 113, which is going to be this one right here, 172.16.6.2, 172.16.6.2 checked. It's Ethernet 114 is going to be the link to server 2, which is going to be this one right here. We're going to create a trunk. We're going to put these ports in trunk mode, and we're going to allow VLAN 11. And so far so good. Let me see what else I can say about. Okay, well, let's do to switch number 3. I'm going to use a different color for the spines. I'm going to use green. So on this spine 1, we only have 2 interfaces that we have to enter. No, forget it. I'm sorry. There's 2 interfaces that we need to make sure we have the right IP address. So let's go to spine 1, which is this one right here, and check interface 112, 172.16.3.1, 172.16.3.1 checked. 113, which is this one right here, we need to make sure it's 172.16.6.1/30. 172.16.6.1/30. That's checked. Let's do spine switch 4, which is this one right here, we need to make sure that interface 112 is 172.16.4.1. 172.16.4.1, that's checked. Then we're gonna check interface 113 on switch 4. It's supposed to be, it is 172.16.7.2, 172.16.7.2/30, and that's it. We're gonna finish with that. Now let's check the parameters for configuring the VGP process in each of the switches, so that way they can exchange routes. So we have to manually enter the loopback interface that I created, and I need to make sure that manually I run a command that says network 1.1.1/32, another command for one of the interfaces, right? 172.16.3, 172.16.3, 2, that one, and then 172.16.7.1, which is this one, and then another command that is going to be entered is going to be to redistribute the connected routes. So that's what it's going to do, is that it's going to take this disconnected route, disconnect the subnet, and it's going to be sharing it into the VGP process. So that's what this command will do. And then exit, and let's check the other one for switch number 2, which is leaf 2. Yeah, it's gonna enter all this. I already checked that. We're gonna redistribute this connected route right here into the VGP process. And another thing worth mentioning is that we're gonna set the router BGP, and we're gonna add the ASN number to switch leaf 1, which is 65020, which is this one right here. So that's checked. The autonomous system number for switch 2, leaf 2, is gonna be 65023, which is this one right here. So that's checked. The one for switch 3 spine 1 is 65021, which is this one. And then for router BGP switch 4 65022, that's the autonomous number for switch 4. So that's checked and checked. I'm not gonna go over this. I already kind of explained that we need to enter the IP addresses for the interfaces manually, and then for the connected routes we do this command redistribute connected. So that's gonna be checked in all 4 switches, and then finally we need to establish the neighbor relationships. So what I'm gonna do here, I'm gonna see if I can get rid of all this, just to clean this up a little bit. Hopefully, yeah, I think it's gonna delete something I don't want to be deleted. So let's try this. Yeah, you know what? Let me try this. Okay, let me get rid of this. Okay, let's clean this up a little, just to finish one of the most important things, right? To establish the neighbor relationships. Okay, so having said that, let's continue. Let's use this color, orange. So switch 1, which is going to be this one. This is switch 2, switch 3, and switch 4. So switch 1 is going to establish a neighbor relationship with 65021, which is going to be this one right here. So that's going to be one of the neighbors, and the other neighbor is going to be 65022, which is this one right here. And then if you go to switch number 2, switch number 2 is this one right here. It's going to establish a neighbor relationship with 65021, and the IP address for that one is 172.16.61. That's the IP address. No, I'm sorry. Let me see. Let me check. Yeah, that's gonna be the IP address for that 65021. And then is switch 2 is gonna establish a neighbor relationship with switch number 4, which is that one. Let me see here. It's gonna be this one right here, 65022, and the IP address 172.16.41, 172.16.41, and that's checked and checked. And then you get the idea for the rest. Is, for example, if you look at switch, let's use a different color here. Let's say that switch 3 need to establish a relationship with 65020 and with 65023, and then let's check 65020 and 65023, and then finally switch 4 need to establish a relationship with 23, which is going to be this one right here, and then not only 23 but also with 20, and that will conclude the establishing the neighbors for the VGP process. So just to recap, this type of topology will serve well in this type of scenario in which you have spines, you have distribution, access switches, for example, and then you're supporting servers, storage, and some other devices, firewalls, etc. And the same thing over here in rack number 2. In order for these routers to exchange routes, we need to establish TCP/IP neighbor relationships, so that way they can share the routes that they know, right? That way, if this server need to hit server 2, then he knows that once he hits this switch 1, it's gonna have the BGP routing table, and it's gonna say, well, if you wanna go to server 2, then you're gonna have to go through switch 4 or ASN 65022, and then down, and then you can go into that subnet that you want to get to that has server 2. And thus this will conclude the overview, and yeah, I guess that's it for now. Thank you for listening.